Module 5, Servers, Hosting, and Deployment. Lesson 5.5, Modern Hosting Models.
In the early days of the internet, hosting meant owning or renting a physical machine. You installed everything yourself, you maintained it, you secured it, you fixed it when it broke. Today, hosting exists on a spectrum, from total control over a physical machine to barely thinking about infrastructure at all. Understanding this spectrum helps you understand modern architecture decisions.
Physical servers.
Let's start with physical servers, also called bare metal servers. A bare metal server is a dedicated physical machine. One computer, one operating system, one tenant. You control everything: the hardware, the operating system, the network configuration, and the security policies. But that control comes with responsibility. You must patch it, secure it, monitor it, scale it manually. This model is common where performance guarantees, strict security, or regulatory compliance are critical. You'll often see bare metal servers used in financial institutions, government organizations, or high-performance workloads. Bare metal gives you maximum control, but it also demands maximum responsibility.
Virtual machines.
Now let's look at virtual machines. A virtual machine splits one powerful physical computer into multiple virtual servers. Instead of one tenant per machine, you can run many isolated environments on the same hardware. This is made possible by a hypervisor, a software layer that allocates CPU, memory, and storage to each virtual machine. Each virtual machine behaves like an independent server. It has its own operating system, its own processes, its own applications. This dramatically improves hardware utilization and makes scaling more flexible. Most major cloud providers built their early infrastructure around virtual machines, including services like Amazon EC2 and Microsoft Azure Virtual Machines. One physical machine, a hypervisor layer, multiple isolated virtual servers. Virtual machines improve efficiency and flexibility, but you still manage operating systems and infrastructure.
Containers.
Now let's look at containers. Containers take virtualization further. Instead of virtualizing entire operating systems, containers virtualize the application layer. A container packages the application code, its runtime, its libraries, and its dependencies into a single lightweight unit. Because containers share the host operating system kernel, they start faster and use fewer resources than virtual machines. Containers are lightweight, they start quickly, and they use system resources efficiently. They are portable. You can build once and run anywhere, on your laptop, in the cloud, or in a data center. Containers are the backbone of modern cloud-native systems. Tools like Docker help create containers, and Kubernetes helps manage and scale them across many machines. Physical server. Application runs directly on a single operating system installed on the physical machine. Virtual machine. Each virtual machine runs its own operating system on top of the hypervisor. Container. Containers share the host operating system and only isolate the application layer.
Serverless functions.
With serverless, you deploy code, not servers. You don't provision infrastructure. You don't manage operating systems. You don't manage scaling infrastructure. Instead, you write small pieces of code called functions. These functions run only when triggered by an event, an HTTP request, a file upload, a database change. The function spins up, executes, returns a result, then shuts down. You pay only for execution time. Serverless removes infrastructure management, runs on demand, and scales automatically. Popular serverless platforms include AWS Lambda and Cloudflare Workers.
Managed platforms.
Now let's look at managed platforms. With managed platforms, you barely think about servers at all. You write code, you push it to the platform. It handles scaling, it handles deployments, it handles uptime. The platform manages scaling, deployments, and uptime. You trade some low-level control for simplicity, automation, and faster iteration cycles. This model is optimized for developer speed. For startups and front-end heavy applications, this model often reduces operational complexity dramatically. Platforms like Vercel, Netlify, Firebase, and Heroku abstract most infrastructure concerns away from developers.
The infrastructure abstraction model.
These are not competing technologies. They are layers of abstraction. As you move from physical servers to managed platforms, you move across increasing layers of abstraction. As you move to the right, you give up control. But you also give up responsibility. More abstraction means faster development, less operational overhead, but fewer knobs to tune. The right choice depends on your team size, your compliance needs, your performance requirements, and your tolerance for operational complexity. No layer is better. Every layer is a trade-off. As abstraction increases, control and operational burden decrease. That is the core mental model. Now your website is hosted and publicly accessible. But what happens when users are far away from your server? That's where CDNs come in.